Hello and welcome back to JD Science Prep. Today we have a video relating to calculating molar masses for molecules. So if you are talking about moles or maybe stoichiometry in your science class, you will have to know how to calculate molar masses for molecules. So it says on the periodic table of elements, each element has something called an atomic mass, which is measured in atomic mass units or AMUs. What it is it's basically equal to the mass of protons and neutrons in an atom because electrons are so small in comparison. However, if you are working with moles or completing stoichiometric conversions, we have to treat the atomic mass as an element's molar mass with the units of grams per mole. So if we scroll on over to a periodic table here, just for a quick example, I already have sulfur squared off, so why don't we take a look at sulfur. So the atomic mass for sulfur here, let me just grab my pen out, there we go, is 32.07 AMU, but if we're looking at a stoichiometric question, what we are going to say is that 1 mole of sulfur, so 1 mole of sulfur, I'm going to write that down actually, 1 mole of sulfur, let me erase that. 1 mole of sulfur is equal to 32.07 grams. Okay, so for every mole of sulfur, there is 32.07 grams of it. All right. Okay, so let's dive into a few examples of our own here. Okay, let's scroll on over. So it says calculate the molar mass of the following. So the first one we have is He, or helium. And what you're going to notice is there is only one helium atom in this question. So it's just He and He alone, 1 helium atom. So let's take a look at our periodic table here. And we're going to find helium. And what we see is that helium has an atomic mass of 4.00. So that means for every mole of helium, there is 4.00 grams of it. Okay, so we can scroll on over and complete our question here. So we just have 1 multiplied by 4.00, and that's an easy question to complete. So the molar mass of helium is just 4.00 grams per mole. That's it, that's all. Okay. Now, getting a little bit trickier here, we have H2, or hydrogen. Remember, hydrogen is a diatomic molecule. It always exists as groups of 2 if alone. So we have H, and there are 2 of them. Let's go find H's molar mass, or hydrogen's molar mass. So we're going to find hydrogen right here. So hydrogen has a molar mass of 1.01. We're just going to keep 2 decimal places. Okay. And since there are 2 hydrogen atoms, we must multiply that by 2. So we'll go 2 multiplied by 1.01 grams per mole. So H2 has a molar mass of 2.02 grams per mole. Okay. All right. We got 2 more examples. We are going to get a little bit more complicated here. Right now we are going to look at H2SO4. Okay, so first, let's count how many of each element's atoms we have. So first off, we have our hydrogen, and we have 2 of them based on our subscript here. Okay. Next up, we have sulfur, and we do not have a subscript next to our S, so we just have 1 sulfur atom in this molecule. Finally, we have one more element. We have oxygen, and there are 4 oxygen atoms in this molecule, so we know we're going to have to multiply its molar mass by 4. So first off, we have to find hydrogen's molar mass. And if you remember from last question, it was 1.01, but why don't we just confirm here really quick? Hydrogen has a molar mass of 1.01, that's perfect. So let's go ahead and write that down. So we know that we are going to multiply 1.01 by 2, because there is that 2 for a subscript. There's going to be 2 hydrogen atoms. Next, we have to find sulfur's molar mass. So we'll scroll on over to our periodic table. Sulfur has a molar mass of 32.07. So we'll write that down, 32.07. And there's just 1 of them, so we will just multiply by 1. So 32.07 grams per mole. And finally, we have oxygen, and there are 4 oxygen atoms in this molecule. So let's head on over to the periodic table, find oxygen's molar mass, and we can see here it is 16.00. We're just going to keep those 2 decimal places. So we'll write down 16.00. So 4 multiplied by 16.00 grams per mole. Perfect. So we have all of our molar masses for each element written down. We must complete our calculations though first. So for hydrogen, we'll go 2 multiplied by 1.01. We'll find that is 2.02 grams per mole. For sulfur, we'll go 1 multiplied by 32.07. That's an easy calculation. We'll just have 32.07 grams per mole for our sulfur portion of this molecule. Finally, oxygen, we'll go 16.00 grams per mole multiplied by 4, and that's going to get us 64.00 grams per mole. And finally, what we need to do is add all of these up. So we have 2.02 plus 32.07 plus 64.00, and what we should get here, folks, is 98.09 grams per mole. So H2SO4 as a molecule has a molar mass of 98.09 grams per mole. And that is that question. We are complete. Let's move on to our last example, probably the most complicating one so far. So we have Ca3PO42. Let's write down what makes up this molecule. So we have calcium, and there are 3 of them, right? We get the subscript 3 right beside Ca. Then we have phosphorus, and we also have oxygen again. Okay. So remember, if we have a polyatomic ion in brackets, this number outside of the brackets applies to both elements inside. So that means we'll have 2 phosphorus from this 2 out here, and we'll have 8 oxygen because this 2 has to be multiplied by the 4 beside the oxygen, so there's going to be 8 oxygen in total. Let's go over to our periodic table because we need to find our molar masses for Ca, P, and O. So we're looking for calcium first. Calcium, let's see where you are. Okay, so calcium, we have right here. The molar mass for calcium is going to be 40.08. So we can write that down beside Ca. So 40.08 grams per mole. Next up, we need phosphorus. So let's go find phosphorus on our periodic table here. Phosphorus is right here beside sulfur. We have a molar mass for phosphorus of 30.97 grams per mole. So 30.97. Perfect. And finally, we need oxygens again. And you may remember it from the last question, but let's head on over there and just make sure. We have oxygen right here, and it's going to be 16.00 grams per mole. So let's zoom out and scroll on over. So we have 16.00 grams per mole. So remember, our next step here is we're going to find the molar mass for our different atoms here. So since we have 3 calcium, we are going to multiply 3 by its molar mass, which is 40.08 grams per mole. And what you should get is 120.24 grams per mole. Phosphorus, you will multiply 30.97 by 2. And what you should get is 61.94 grams per mole. And the last one, oxygen, we must multiply 16.00 by 8, and we will get 128.00 grams per mole. And we just have one more step here. Let's add all of them up. So we'll add 120.24 plus 61.94 plus 128 to get a molar mass for Ca3PO42 of 310.18 grams per mole. Okay, so I'll write that next to Ca3PO42. So we have 310.18 grams per mole. Okay, so that is calculating molar masses for molecules. If this video has helped, like and subscribe.